So far we've looked at simple interest, and we've looked at how compound interest grows faster than simple interest because it adds the interest back in at regular intervals, and then interest is calculated on interest, and that causes interest to grow faster. And again, I've said that sometimes that's described as a snowball effect, as the interest keeps accumulating, sort of like the way snow accumulates on a snowball when you're trying to roll it around. It grows faster the more you get. What we did last lesson, though, is we used the simple interest formula to calculate compound interest, and that wasn't a lot of fun because if I wanted to find out compound interest on an investment, say over 10 years, at step by step I had to calculate the interest for year 1 and then add it to previous year, and then do year 2, add that, year 3, and I had to do every step along the way, which can be really time consuming and tedious. Luckily, we don't have to do that normally. The purpose of doing that last lesson was so that you could see how it worked, but now we're going to look at a much shorter and easier way to do it. So that's basically what I'm saying in the first paragraph here. It's just that compound interest, the main takeaway is that compound interest calculates interest on principal as well as previous interest, so it grows faster than simple interest. Now, here's what I'm going to give you to make things go faster. It's a formula for calculating compound interest. A equals P times 1, that's the number 1, plus little I. I'm going to write that little tail on the I so that it's clearly different from a 1, and that's inside brackets, and that's to the exponent n. So we just got to point out a few things about this. The first one is this formula calculates final amount, okay? A, remember, stands for final amount. Just like in simple interest, the final amount is the principal plus interest. So it's the exact same thing. P stands for principal. That also is the exact same as what we understood P to stand for in the simple interest. So those first two variables that we see are exactly the same as how we've been using them up till now. But it is important, again, to remind you that this formula is a bit different in that it calculates the final amount. It calculates the interest and principal added together, whereas the simple interest one only calculated the interest. So that is a change. But here's two new variables. The first new one is this little I. Little I is the interest per compounding period. Okay? Remember, in simple interest, we use the letter R to represent the interest rate. So if we talked about 10% interest or 5% interest, R would be 0.10 or 0.05 respectively, once we change it from a percent to a decimal. We have to do things a little differently for compound interest because things aren't always compounded once a year. So what they do is they take the interest rate, the yearly interest rate, and figure out how much that would be per compounding period. That would be just trying to think of a way I want to rephrase it here. That would be the same as if you take R divided by the number of compounding periods per year. And again, I know that compounding period is a new term for you, which I'll explain a bit more later. But this is how we calculate I. We take the yearly R, what we know as R, the annual compound rate, and divide it by the number of compounding periods per year. And N is the total number of compounding periods. And so the way we calculate that is we're going to multiply the number of compounding periods per year times the number of years, but that's explained below. So first of all, what do we mean by compounding periods? Compounding periods are assumed to be annual. So when we did simple interest and we talked about calculating the interest for 5 years or 6 years or whatever, we assumed that they're going to calculate that interest once a year, 7% once a year. If we get $70 one year, then we'd have $140 the next year and $210 the next year. So in other words, you'd get $70 a year, but they did it exactly one time a year. But we don't have to do that. So here's some different terms we have to look out for. Annual means once a year. And if it doesn't specify that, then we'll still assume that we're calculating the interest once a year. Semi-annual, if you see the word semi-annual in a question, it means that there's going to be 2 compounding periods per year. If it talks about quarterly, then it'll be 4 periods per year. Monthly will mean 12 periods per year. Daily would be 365 periods per year. You could, in theory, calculate the interest every single day. And that means that you'd only take a portion of the interest every day, but then you'd add it back in. There's one left out here. I'm going to add it in here. Just remember, weekly, we did say weekly is a possibility. That would be 52 times a year. So we have to look out for all of these words in a question. They will give us important information. Remember, interest rate per compounding period, we divide the annual interest rate by the number of compounding periods per year. That's what I was just explaining up here. So again, an example will help this a lot. Number of compounding periods, n, that's the total number of them. In other words, how many times has the interest been calculated overall? Well, what we want to do is we want to multiply the number of years that have gone by times the number of times per year they do it. So if you're calculating the interest twice a year for 10 years, then you'll have done it 20 times. That's all that n is telling us. So, calculating some values here. So before we actually put the whole formula together, let's calculate some values. So we need to know what P, N, and I are, right? If you look at this formula up here, we need to know P, we need to know I, we need to know N. If we know those 3 variables, then we can calculate the final amount. So, for this one, $400 for 4 years at 4% compounded quarterly. Well, $400 is the principal. It's the amount invested. It's 4 years at 4% compounded quarterly. So we need to use the 4 years, 4%, and quarterly. All of those things are important. So I want to get I. So remember, I is the rate, 4%, but I'll change it to a decimal, so 0.04. And then I'm going to divide it by the number of times per year we do it. Number of times per year that we calculate the interest. Quarterly means 4 times. So once per quarter means every 3 months they're going to calculate interest. The reason we divide the annual rate by the number of times per year they do it is because you're not giving all the interest at once. In other words, if I want to give out 4% interest, but I want to do it 4 times a year, then I give out 1% at a time. Give out, say, 1% in January, another 1% in April, another 1% in July, another 1% in October. Then 1% 4 different times adds up to that 4% for the year. And then N, how many times are they calculating the interest all together? Well, you're doing it for 4 years. But again, 4 times a year. So now I'm going to multiply times 4. And so overall, if I do 4 times a year for 4 years, we're going to calculate the interest 16 times. So notice how when we calculate I, we take this percent and divide it by 4. And that 4 is from the fact that it's quarterly. So it's 0.4%, 0.04, divided by the 4 because it's quarterly. When I'm calculating n, it's 4 years. That's where this 4 comes from. But again, it's because it's quarterly. So that word quarterly actually gets used twice. Once when we're calculating I, once when we're calculating n. Because all the numbers involve 4s here, it might be a little confusing. Let's take a look at another one. So $1,000 for 10 years at 6% compounded monthly. So the principle's easy. That's 1,000. But it's 10 years. It's 6% annual. That's our R value. But it's compounded monthly. And so how many times a year is monthly? We just have to know that how many months are in a year. It's 12 times. Okay? So P is just a straight 1,000. I is the 6% as a decimal divided by 12. And 0.06 divided by 12 is 0.005. And the total number of times that they're going to calculate the interest overall is 10 years, 12 times a year, for a grand total of 120 times. So they're going to give out 0.5% interest, 0.005 interest, 120 times, and they're going to keep adding the interest back in. That's what the compound part means. So let's calculate the amount for each loan. So basically, we're going to do the exact same thing, except that we're going to actually work it out with the formula now. So P, I still write all the values down. P 2,500. I was the 8%, and so 0.08 divided by semi-annually, that means twice a year. 2 times a year. So divided by 2. Which works out to 0.04. N is the 4 years times 2. Again, hopefully the highlighting makes things a little clearer. Notice how these two things that I've highlighted in blue, in every case, are the exact same. 2 and 2, 4 and 4 here, 12 and 12 here. It's because I'm using the same number based on quarterly, monthly, semi-annually each time. And the only difference is I divide when I'm calculating I, and I multiply by that number when I'm calculating n. So that equals 8. So now that I've got these and I put them together, I've got A equals, remember A equals P times 1 plus I to the n. So that equals 2,500 times 1 plus 0.04 to the 8. Now, usually, just to explain what I'm doing, I'll write this down the first time, but adding 1 to anything just means that I could write that as 1.04. And from now on, I'll do that. I just wanted to show where it comes from for this first time, but really it's just 1.04 when I calculate that. And then I can follow order of operations. My calculator will do it for me if I do 2,500 times 1.04 to the exponent 8. Or I could do order of operations myself. I could do 1.04 to the 8 myself and then multiply by 2,500. But order of operations does have to be maintained. That works out to be 3421.42. So that is the final amount. So in other words, to interpret this, it means if you invest $2,500 for 4 years at 8% and they compound it semi-annually, at the end of those 4 years, you'll get to take home $3,421.42. So here's a couple other examples of that. Let's just go through them. 500 is the principal. I was 0.06. Quarterly, we've seen, means 4. So 0.06 divided by, we're always dividing for interest, divided by 4, which was 0.015. N equals the 15 years times 4. Get some highlighting going on here, which is 60. So the final amount would be 500 times 1 plus 0.015. So I'll just write 1.015 like I showed up here, right? Remember I showed you add them together and you just simplify it. Don't need to write it as a separate step, in other words. And the exponent is 60. That works out to be $1,221.61. So actually, once you start to get the hang of this, doing these compound interest questions are really quick to do. You identify P, I, and N, put it in the formula, type it in, and you're generally done in about a minute. Let's see if we can do this one in a minute. P equals 750. I equals 0.045 divided by what? Divided by 52. Now this time I get a long decimal, 0.045, sorry, looking at the wrong numbers there, 0.000865. I would, for interest rate, this is important, carry lots of decimals. Because a small change in interest rate can make a big difference in your answer, okay? Then we had, for N, we had 12 years also, times 52. So divide by 52 for I, multiply by 52 for N, and we get a big number, but that counteracts the small number we got for I. 624 is what that works out to. So A equals 750 times 1.000865. Again, I just combined the 1 and then the I value together to the exponent 624. Put that in my calculator. Works out to 1,286.70. I'm rounding to 2 decimal places because that is to the nearest cent. Okay, the last thing I want to do for today is just remember this value, this formula, in each case here is calculating A, my final amount. A is the final amount. What if I just wanted to know the interest for a loan? Well, I can get that as well. And I can use the this formula. Remember we had the formula A equals P plus I from simple interest, but we could also rearrange it if I wanted to get I by itself. It was equal to A minus P. So interest, dollar amount of interest is equal to the final amount minus the principal. That's all we'll have to do. So let's do one more example just to show how that works. Calculate the amount and the interest paid on a $900 loan. P is 900. After 5 years, that's my time, at 12%, that's my annual interest rate, and compounded daily. Okay, how many times in a year is daily? 365 times. So I is going to be that 12% as a decimal though, divided by 365, which again is going to be an awkward, long, small decimal number, but we do need to get lots of places there. So 0.000329. I would go to at least 6 decimal places when we're doing this interest rate thing. N is going to be the 5 years times 365. So that's a big number. Again, that balances out the small interest rate each time, 1,825. A is going to equal then $900 times 1.000865. 329 to the exponent 1825. That works out to be $1,639.74. So that's one part of my answer. That's the amount, but I also want the interest paid. So remember, the interest is the difference. It's the final amount minus the principal. So if we ended up with $1,639.74 and we started with $900, the difference between them must all be interest, right? And so that works out to be $739.74. That's our interest.